Go! Today's on 6-2. Day 1, mechanics of substitution. Day 2, practice with it and a little bit of word problem translation. I know it's been a week since you've been in here, but let's see what you got. But I don't know. Did you? I don't remember what I had for dinner last night. You're asking me if you were in class last week?
Why do I not remember this stuff? This is so bad. Yeah, like we did all this, probably.
We finished off all of 6-2.
Yeah. I must have been gone.
Ruh-roh.
Should I just send it?
You got a choice. Oh my. Okay. That one's here, that one's here, that one's here, that one's here, that one's here. That one's here. That one's here, that one's here, that one's here. Here, 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 here. 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 Here and here. Cool beans. I remember we wrote down a bunch of cheaters for the 3 ways that these show up in word problems. In fact, this one is written almost identical to the ones from your assignment.
What's my other option?
Option 1, you go for it. Option 2, you don't. You need to make it up. I gave you a different problem. It is worth noting, I said this all last week for those of you who were not listening or paying attention. I was gone yesterday for Spartan time. I'm gone again tomorrow during Spartan time. So if you got to come get something done, you got to come get it done before or after school.
How late are you staying today?
It depends if I have a compelling reason to stay, because goblin number 2 will be here about 3:30, 3:40. Normally, if I have to pick him up, then I just trade out in the parking lot and leave. But if I have a compelling reason to stay, I don't know, whenever. So that's 1, 2, 3, 4, 5. Quiz. That's a lot of review time. That's a lot of review time. Decimals can be hard to read from afar. That is 2125, 125, and 250, respectively. Okay, there are decimals in there. No, it was not $250 for a cookie. For those who got an idea what they're doing, is anyone still rolling? Okay. Let's put this one away and grab one from the side. You two, remove temptation. Okay. You two, remove temptation. Okay.
But doesn't monster cookies beat them? The 12 that you.
They are all monster cookies. It's just whether they're regular or vegan. Monster cookie just big.
Oh, okay. So this one would be 12, right?
Yes. Don't overthink it. It follows the same pattern that we went through before. Now remember, even if you can puzzle this out just by guessing and checking, that doesn't count for this or test day. Write a system, solve it by substitution. That's a skill that we're learning, that's a skill that we're measuring. As soon as we get going here, we're going to ditch this. Okay?
Yeah.
Okay. Okay. See a couple furiously scribbling. We'll give you a minute. Set up the same way as at least one of our examples, at least one of our homework problems. Defense. Defense. Let's just hope that my defense is better than the Spartan usual. All right. Gotta get going here. First things first, you look at the question. The question tells you what the variables are. Identify your variables. How many of each cookie did you buy? So, very first thing that you should do is label what are your variables. How many of each cookie? Well, there you go. The two different kinds of cookies are your variables. You got regular and pita. Vegan. So, do you want to use those variables or do you want to switch them over to X and Y? Because it actually doesn't matter. Okay? So, I'll say regular and vegan will be X and Y. So I label that to begin with. Next up, make my equation. My equations come from our three types. Either we have slope-intercept form, rate x plus start. Did they give me in there you start with this much and then add so much per cookie? No. So it's not that kind. Very rarely we will see point slope form where they give me a rate and then a specific data point, like you pay this much per cookie and in this week you normally spend this much, like a input output. That doesn't sound close to what I got up here. So they're in standard form, which is rate X plus rate Y equals total. And when we do one variable or two variable linear systems, very often they're written like that. So find my totals, because the totals tell you what goes with them, because they share a label. What are my totals? Okay, 2125 is a total, and it's in money. So if 2125 is in money, then the two rates that are going to go with it are the ones that are in money. Money goes with money. So total 2125, rate for X, X is regular, regular is $1.25. 2125 is in money. Money goes with rate. Rate of vegan in money was $2.50 each. Okay, so I've taken care of this and this and this. Are there even any other numbers in there? A dozen. A dozen what? Cookies. So this is one of those that tended to trip us up last time. I know I said it's been a week, but if my total is just 12 total cookies, they didn't say anything like you have twice as many regular as vegan. They just said you got cookies. So this many regular plus this many vegan. X plus Y is total of 12. After that, it says solve by substitution, and you get the choice. Who do you want to get by themselves up there? X or Y, top or bottom? Which one?
Bottom.
I'm probably picking X or Y from the bottom equation because they both have a coefficient of 1. 1's really easy to get by itself. So I'll start by subtract Y, getting X is 12 minus Y. If I know that X is 12 minus Y, then I rewrite this 125 with something X, but it ain't X anymore. 250Y, 2125. And now I'm going to plug in, if X was this stuff, replace X with this stuff. You now have an equation that only has one variable in it. Solve it like you're back in first semester. What's 12 times $1.25? You sure about that? Yeah. Man, just make you doubt your whole existence there. 125 times Y is 125Y plus 250Y is 2125. We always combine like terms wherever possible. The Y's and the Y's go together, making 15 plus 125Y. That's 12.5.
Drop the negative. What? Oh.
Negative plus positive altogether. I know it kind of confuzzling because it happened to be the same as one of my terms. And then Play the Who's Lonely game. Subtract 15 from both sides. Getting 625. Divide both sides by 125 and get y is 5. So often we get there and we're like, cool, I got variable equals number, I'm done. Whee! Make sure you come back and finish it off. We said x was 12 minus y. We just said y was 5. Okay, so at the end of this, you do have to say there were 7 regular and 5 vegan. Because it does ask how many of each. You two all right?
I was gonna be off. I almost got it.
Yeah? Uh-oh. Like,
Back is there wrong? I did double checking.
X, Y, X, Y. So you got that. Okay. Okay, you had it all set up right, too. But right here, how did you get X is 11? Or Y is 11?
I did what we did here. Subtracted.
Oh, see, right here we were able to put in 1 because we had already found it. Here, I don't know what that is yet, so I take this whole thing and plug it in. Okay, so you're following the right process. We just kind of jumped the gun and put a number in instead of the amount. I'd call that, I mean, you were able to, here, let me write the points up here. Let's get, first things first, this whole thing is crap if you can't write the equation in the first place. I'm putting 2 on that. Just, you wrote the equations correctly. 1 for each of the equations. I'm going to say 2 for the solving process. And then finally, 1 for your final answer. Did you actually answer it? So like in your case, your process is all good. It's just right here, instead of plugging in that and solving for both, you plugged in a number and solved for both. You still have your equations. You still went to the end. You still checked your answer. I'd call it 4 out of 5. Okay? Yes?
So I tried to follow along and do this first one.
Mm-hmm.
So how do I find X and Y like that? Cause okay, so I put in X equals that.
Mm-hmm.
So
You replace X with stuff. Divide. Y is 20.
Oh, Y is 20, and then I put that in.
Yeah.
Okay, so
Okay. Now, I am going to assume that a week later, if no one has asked a question, we got no questions. If you do have questions, A, where were you the last week? B, gonna have to come in on your time now. Okay? Because that we had a week. We had a week. And I really want to go through all, if at all possible, of 6.3 today so that we can have a second dose of it on Friday. Okay, when you look at the back, now that we're on the last stretch, when we hit the, okay, ADHD go Bert. So normally I forget to update that calendar section of the board. That's why I never have anything there. Just don't even bother because I'm going to forget. But during this last stretch here, this last 8 weeks or so, right? It's six or seven until your final. 6. During this last stretch, I'm going to have that board updated. Y'all are blue because you got the blue book. But 6-3 today and Friday, you'll have quiz 11 on the 26th, barring any weirdness. In addition, y'all know that you got Freshman Impact on Monday. Okay? Freshman Impact is not optional. You go. It's basically scare tactics. Okay? They're going to have you do different activities. They got a whole like bring in the life flight chopper, cut someone out of a car kind of thing. It's basically don't be dumb. We're going to try to scare you with what happens when you're dumb, particularly as you're driving. Okay, they get a lot of the local first responders involved. It's a big old thing. They bring in kids from other schools. Um, I had something similar even in Podunk, North Dakota. I had grades 7 through 12 was 300 kids. We still had something like this. So it's an all-day thing. That is your Monday. Okay. I'm just letting you know it might get a little weird though because right now, Friday night through Saturday, Spearfish is supposed to get a foot of snow. Yeah. But it's actually the weather center right now is calling it 99.3% chance or something. So um, this one probably won't miss us like the last one, but the track can shift. So if the parking lot is full of snow, they might, instead of the various activities outside, bring some of them inside into the gym. I don't know. Um, they're going to have to play it by ear. They always got backup. Okay. Yeah.
Is freshman impact just for the freshmen or is it all the students?
It is just for freshmen. Last year, it was freshmen and sophomores because the previous spring we were shut down and the freshmen didn't get to do it. So, yeah, just let you know, calendar's going to be up there. Blue stuff is you. Right now, we are on track to finish chapter 6, which is where we're supposed to be. And then we'll probably have 3 days of review in class before your final. Your final is worth 10%. It's the border buster. Get higher on the final than your grade going into the final, assuming you have done 80% or more of your homework and notes for the semester. That's your new grade. It's grade replacement for those who are actually doing what they're supposed to. So, um, yeah, I don't do extra credit. Extra credit is artificial grade inflation. Y'all know already the class that you can just show up, kind of pay attention, bring in Kleenex, and you got an A, right? No, you're going to know it here. If you don't know it, your grade shows that you don't know it. But if we have a cumulative final that covers everything from the semester, and you show me on a cumulative final that you understand it better than your other stuff, why shouldn't that be your grade? I've had kids roll into the final sitting at a 85, aced it. Cool. 100% for the class. Good job. But that's about 6 weeks away. Ironical that they're talking about. Oh, wait, no, it's fruit. I thought it was eggs. Not eggs. No Easter Bunny for you. Reason it out. See if you can figure it out the same way that these problems were set up last time by our words. Maybe you're going to do it by proportion. Okay, because today we do elimination, and personally, that is my favorite as opposed to
actual like data. Like that's what how much
37 ounces. And well, think about it. A pound is 16 ounces. So this is 2.5 pounds.
Yeah.
Yeah, for a couple pieces of fruit, I'd see it.
Can't really tell which is which.
What do you mean, tell which is which?
Oh, just kidding. Yeah, I'll marry again.
Okay. All apples are the same. What is the weight of an apple? Oh, apples and oranges. I see what you're saying.
No, just picture wise, you can't really tell.
Okay. So, well, Apple got the them little apple bottom jeans, right? Versus orange, orange, orange. But I see no boots up there. So, just apples and oranges. Okay. What do you think? See who comes up with the common sense way to do it. We don't need to be playing around with that either. Remove temptation. Okay. Okay, if you did it right, they both come out as whole numbers. And what would you call it? 7-Eleven's creepier cousin? Okay, as soon as I show you, you're going to say, oh wow, that's way easier. Mm, pink? Pink.
I'm like almost there.
What do you, okay, all right, all right. Has anyone got a guess? Both whole numbers?
Take the difference in weight and then take the difference in number of roots. So there's 2 extra oranges.
That's exactly it. Okay. If I have here 3 oranges and 2 apples at 37 ounces, then I should be able to take 3 oranges and 2 apples off of this guy, and it will take 37 ounces off of there. That's hold on. I'm already thinking ahead for the apples. Um, so if 2 oranges is 14 ounces, then orange is 7 ounces. Well, if orange is 7 ounces, that means this is 7 and 7 and 7 and 2 apples. So take 21 off of there for the 2 apples. You get 16. Divide that by 2. 8 and 7, right? 7, 11, 7, 8, 7, 8, 9, the cannibal, creepy cousin. No. Come on, math jokes, right? I have my pre-calc sending me trig memes right now as their assignment while juniors are testing. You nailed it right away. Is I find the difference in them. If I subtract this stuff from that stuff, or if I even add this stuff to that stuff, then I ended up with only oranges. That means I'm down to one variable. That was the whole goal of substitution. I wanted to be in one variable. Two variables, too much. One variable, I can do that. It's called elimination because I can eliminate a variable. Just yeet it out of there. It's gone. You got to remember that an equation is a balance. Okay? Y'all remember the whole teeter-totter thing? Right? The equation is a balance. What you do to one side, you do to the other. So let's say right here, this is the fulcrum on the teeter-totter. This side balances with this side. I don't know, Sailor ate a really, really big lunch. Okay? There's the teeter-totter right next to him. I say this side balances with this side. Okay? Ava's got an adamantium skeleton or something. Right? Shouldn't I be able to take you and put you on that teeter-totter? Shouldn't I be able to put you three on a side and you three on a side and it balances? If this balances with this and that balances with that, then all of this balances with all of this. Should work. And it happens so quickly and so easily. Look at what happens when I add these two expressions together. 2x's and 6x's is 8x's. But 5y minus 5y, whoop, gone. 17 minus 9 is, okay, divide. Look at how fast that is. I love elimination. Now, we did only find x. Remember, if you have an x, you better find out y. Which equation do you want to plug that into?
The top one because it's a plus.
Okay, the top one's got positive numbers in it. I don't want to deal with negatives. That's as good a reason as any. It doesn't matter. You can actually use either one and it's going to work. But if we have 2 times x plus 5y is 17, we just said that x was 1, so plug it in. So I got 2 plus 5y is 17. Subtract my 2 from both sides. Divide both sides by 5. Make sure to write your answer as a coordinate. 1, 3. Because remember, if I were to graph these two lines, this is where they would cross. It's really that easy. If I add, or sometimes even subtract, one equation to another, and I'm able to make one of those variables just poof out of existence, like you did with the apples, then all that's left is one variable. You eliminate a variable. And this has always been my jam. I love this so much more. But you got 2. Give them a whirl. I tell you, they're already set up nice. Just add x's plus x's, y's plus y's, constant plus constant. Okay? Because if you do, the way they're set up right now, something will eliminate. When I add these expressions together, y's disappear. Watch your signs. You end up with 16 on this side. Divide, x is 2. When I add these two equations together, my x's disappear. I've been saying since last semester, put that 0 there to show yourself negative 3x plus 3x is 0. Because when you put the 0 there, you should see those negatives are still there. That's negative 7y is 14. Or did we miss it? If you put that 0 there, hopefully the negatives are still in place, and you remind yourself this will be a negative. Divide, y is negative 2. Now in both cases, you have to go back and find, if I know x, find y. If I know y, find x. And which one you plug that into doesn't matter. So I'm going to choose the bottom one just because, again, all positives. I like that. Say 3 of thing plus 6y is 48. We said thing was 2. So 6 plus 6y is 48. Subtract 6. Divide by 6. Right coordinate. Contestant 2, you got room off to the side here. I'm just going to write it up here because I'm running out. Doesn't matter which one I plug it in. I'm going to use bottom one again. 3x minus 4 of the these is 5. The these we now know is negative 2. So 3x plus 8, subtract, divide. Write your coordinate. Okay, elimination. I mean, it depends. If they tell me y equals stuff, then I'll probably go with substitution because they have it already isolated for me. It's easier to work with. But if they don't say y equals stuff or x equals stuff, I'm probably using elimination because in my experience, it's just faster. You notice all three of these problems, if I just add stuff together, poof, something gone. It doesn't always work out that way. This one would be like, okay, well, Preston said if I subtract instead. But they can't just give it to us easy and say, here's an equation, now do it with subtract. We got to practice our words. So, read. Do you see a rate? Do you see a start? Do you see a total? What do you think? Can you write the equations in the first place? Then I'll go through the solving. Okay, I like the few of you that I'm seeing are already writing off to the side your coordinate, x, y, and labeling them. I have kids up in Algebra 2 that I can't make do that, and then they get their labels wrong at the end of the problem. Okay, it's a real good habit to have right now. The question at the end is something I don't know. In math, if I don't know, I put a variable. So the question tells me what my variables are. How many student tickets? Okay, so I'm going to say X is student because that's what I don't know. So if X is student tickets, What is the other thing in the problem that goes with it? Adult tickets. Next up, did they give me totals? Those are probably the easiest ones to write. They even said the word total in there. Total ticket sales, 164. Well, ticket sales was in dollars, was in money. So if it's in money, then my X and my Y better also have money with them. X was student tickets, so go find money for student tickets. $1. I don't have to put the 1 in front of it, but you can if you need to. Adult ticket, Y, adult, money, money goes here. Okay, so I used this, cross it out. I used this, cross it out. I used this, cross it out. The other thing that they told me was total. Total tickets. Total tickets. They don't say you have 3 times as many students as adults. They don't say you should have 5 adults for every 2 children. They don't say anything like that, so what do I put on the other side? Just X plus Y. Adult tickets and student tickets, all done. Okay. So now, Preston, you're the one who cracked the code the first time. Words!
Subtract the bottom one.
If I subtract it instead, right? If I add them right now, I'm not getting rid of stuff. If I add them, I got 2x plus 350y. I don't want that, because now I still have 2 variables. I want to eliminate a variable. So instead, I'm going to subtract this equation. Now, I'll tell you, in my experience, kids are going to forget to subtract one of those 3 terms. Are you going to remember x minus x, 250y minus y, and 164 minus 101? If you're going to, great, do it. Cancels out, get 150y, get 63 instead. Option 2, if I don't like that, what you can do since you're subtracting it, I could just change all the signs, because that's multiplying the entire thing by a -1, right? Take this side times -1, that side times -1. Math is communist. What you do for one, you do for all. Multiply every single term by y, or by -1. It still cancels. It still gets 150. It still gets 63. They're just different ways to think about it. Depends on your jam. Okay, this is how the book sets it up. But personally, I'm a fan of just multiply, because that's something we're going to have to do going forward here when the numbers don't line up nice. Now again, you do have to finish this. What is 63 divided by $1.50? You had the golden opportunity there. You say the meaning of life. Hitchhiker's Guide to the Galaxy. No? Get cultured. You don't know half of the references we... All right. If we say y is 42, then plug it back in. Find the rest that goes with it. We said x plus y is 101. We just said y is 42. Subtract. So x is 59? Yeah, 59. But make sure you answer the question. I found x and y. Woo! Yay! Did you answer the question? How many student tickets were sold?
59.
Okay. 59 student tickets. Okay. I'll give you a minute. First things first, I want you to write the equations. Don't start solving them yet, unless you feel real confident. Can you write the equations first? Then I'll have you solve. After we get the correct equations up there and we're sure we're all on the same page.
Sorry, I just heard you. Were you coming around collecting that stuff? Yeah. I put the bowl of fruit in the lounge, but I stuck the one that's left.
Will it always be in the X plus Y?
Not always. Now today, since we're doing elimination, a good chunk of them will be. But as we go forward, and what I hope we can practice on Friday is, what if I just give you stuff? You rearrange it.
I need to rearrange it.
Well, you rearrange it to which way you want to. If it's easier to rearrange to do substitution, do it. If it's easier to rearrange to do elimination, do it. Pick your pick, whichever jam yours is. I have a kid, was it last year, 2 years ago, would do our 3 variable systems by substitution every time, even though everyone else in the room hated it with a passion. That was their jam. Right now, we're learning elimination, we'll do elimination. But after this, if I don't tell you a specific way, you do it however you want. Okay, do we have now whether you use X or Y, C and T for car and truck, A and B, I don't care. Did you label off to the side what's what? But that's what you should have for your equations. Okay, now that you have the equation solved. See how it was rate X plus rate Y is total again?
The question is, what would be better, add or subtract?
Well, if I add them right now, will anything disappear? So I should subtract.
So that's
Okay, if I subtract just as is, the way I wrote it, I get a double negative. But that's okay, because as soon as I divide, negative divided by negative, get T is 30. There's 30 trucks. So, plug it in. 2C plus 3 of those We said there's 30 trucks. So altogether, 2 cars plus 90 is 130. Subtract. 2 cars is now 40, so C is 20. 20 trucks, 30, or 20 cars, 30 trucks. Now, the order you do this in doesn't matter. Could I instead... Oh, now you're going to keep them all together? Stupid Frank. Could I have put 2C, 5T, 190 up top? Just so I'd have positive numbers. Okay? Sailor doesn't like negative numbers.
That's what I was wondering. Are you allowed to?
Yes. In fact, as we get into these, there are 3 rules when it comes to systems. Number 1, you can multiply any equation by a number whenever you feel like. Okay? If this equation balances, if this teeter-totter balances, could I just triple everyone's weight on that teeter-totter and it still be balanced? Yeah. Number 2, I can swap rows at any time because it just makes more sense for me. Isn't it still this balance with that balance with this? Yeah, the order I set it in doesn't matter. And number 3, at any time I can add any 2 equations together. You can say, but I'm subtracting. Isn't subtraction a lie? I don't subtract, I add the opposite. I add a negative, right? So those 3 rules, in fact, we use those to start 3 and 4 variable systems later in math. Because I started blabbing. And I forgot. How long does it take to wash each type of it? Now, if I graph these, they would be a coordinate, but I put C and T. What if you put X and Y? What if you put Y then X? Your graph would be the opposite of mine, right? So it all depends on how you labeled it. That's a good thing to bring up here, though. What happens if I have a system that's not X and Y? How do I write the coordinate? Do I do T then C or C then T? Okay.
Yeah.
It depends on the setup of your word problem. It depends on if there's no context to the word problem. They just gave you this, nothing else. I would actually write C then T because alphabetical order. You notice it's always X then Y. Okay? But as long as you label what they are, nah, it don't matter. It really doesn't. Oh. Freshman. So. All right. So as Preston over here, I kind of want to just, but I've done that before and I know that these launch pretty good. Like, seriously, with the ball on the end? Like, take your eye out, man. No, this does not work right now. If I add or subtract these equations right now, nothing eliminates. Right? If I add those 2 together right now, 5x, 10y, negative, what's that, 15? Yeah. Nothing went away. So can I alter one of them? Can I use one of those 3 rules? Could I triple the weight of this side? right? So the way that we normally write these out is I'd have my negative 2x plus 15y is negative 32. 7x minus 5y is 17. Okay. The way that we would normally write these on paper, it's just a method of organization. You do it however you're going to do it. Again, this is experience talking. Is I'm going to take this equation and I'm going to multiply it by something. What should I multiply it by so something goes away? Okay? If I take this equation times 3, and I'll even write it here so that I know what I did. Okay? I'm not touching the top equation at all. I'm just going to write it again. Affect the way the what? I want it to be a negative, don't I? Because when I multiply this now, I've got positive 21x and a negative 15y is 51.
So the numbers you talk match up the signs.
Yep. You want the coefficients of either x or y to be opposites. You want a 38 with a negative 38. You want a positive 1.5 with a negative 1.5. As long as that happens, you're good. Because now something eliminates.
How did you times? Oh, it's a 7. I thought you times. Yep, no, we're good.
Okay.
Yep.
And 51, 32, 83. Right? Oh, that is a negative. Whoop. Good thing I didn't finish writing it. That would have been close. And divide. Anyone know baseball rules? If one of the fans reaches over, catches it for just a second, and then drops it into their glove, does that still count? Like, what's the difference between I caught it, dropped it in their glove, versus it bounced off my glove and you caught it? Are they still out?
I think it's like you're still out.
Right?
Yeah.
I'm thankful for the assist, whoever stopped me. X is 1, go all the way back to the beginning. If X is 1, you got to figure out Y. I'm going to put, which equation do you want to use? Actually, it doesn't matter, but do you have a preference in Y?
The bottom one is less.
Less negatives? Smaller numbers?
Oh.
But, right? I just want to know what your reasoning is. Why are you choosing it? Both of them work.
Multiplied by 3 and those are bigger numbers. It would be easier to do top one. They both have one negative, so.
Okay. It really does not matter. Top, bottom. Bottom it is. So I've got 7x's minus 5y is 17. In there goes 1. So 7 minus 5y is 17. I'll subtract 7 and divide by negative 5. We go to the end. 1, negative 2. And done. Okay? So sometimes you have to multiply in order to make this thing work. So, same thing here. You can't do this by elimination right now. Can you multiply one of the equations by a thing to make something eliminate, to make something go away? Mm-hmm.
So, since this is its own term, would y be negative 2? I didn't see.
Yeah,
what the
-2.
answer
Yep,
was.
just divide it.
Oh, even though the answers are still the same, that doesn't work. It has to be
Has to be the what?
It has to be one of the X or Y's. Can't be this 6. If you minus it would just be 0.
So, 0 is a number.
So I don't have to multiply it.
No, keep going. Keep going, you're right. What you did here, got this, now write this equation right below it, and keep going.
No.
You're right.
No, what I'm saying is like, you know how you can add or subtract this?
Uh-huh.
If you minus 6 minus.
And 0 is a number too. Stop hating.
Okay, never mind. Yeah. Okay.
Can we sometimes get 0 for an answer?
Sure.
Yeah.
So, where did you get 3? I don't think I was in the room for this problem.
You have to multiply something. Can I take -2 times something to make 7? Like 3.5. But I'm guessing you don't want it to go to decimal or fraction. Can I take -5 times something? That's why we chose 3, because it was a one-step multiplication instead of having to do fractions or anything else. Now you can work with fractions. If I had done this whole thing times 7/2 or 3.5, it ends up really gross, but it would still work because now you'd have fractions everywhere.
So how do I know what to pick
Well,
on my own?
can I take this times something to make 3 or that times something to make -5?
No.
Can I take 2 times something to make 6 or 6 times something to make 2?
Yeah.
Yeah, 2 times what makes 6?
3.
There you go. That's the thing you choose because it's one shot, one step. Okay?
I have a question.
Eh?
So is that going on the right path? And then I'll just put that in there and we'll be good.
Yeah.
Okay.
I was hoping you would catch that, but if you had 6 minus 6 and get 0, then I would just have -12x equals 0, divide x is 0, which would be perfectly legal. But you caught it. You caught it. You're good. What'd you multiply by and which equation? Okay. So if I do 3 times the top, and I'll write that so I know what I did, get -15x minus 6y is 18. We don't touch anything. 3x, 6y, 6. And now, because I have opposite coefficients, when I combine those two, when I pile everything on one seesaw, it works. I get -12x, bye-bye, and 24. I divide and get x is -2. If you have an x, you better find out why. Plug it into one of them. Got a preference? Bottom one's got all positive numbers in it. So 3 of these plus 6y is 6. We just said X is -2. Solve. -6 plus 6y. Play the Who's Lonely game. Add 6 to both sides. Divide. Did anyone do it a different way instead of multiplying by 3?
I don't know, you could have multiplied the bottom one times 5. Right?
Okay. I can do the bottom one times. Well, if we're back to the original, white, I could have taken this equation times 5/3, right? 5/3 times 3 is 5. I got 5x and -5x, they'd cancel. But look at all the, actually, wait a second, 5/3 times 6, that's 10. 5/3 times 6 is 10. I would have had whole numbers. Would have been perfectly legal. Is there anyone who spotted this? Because if I take 6y divided by 3, I got 2y, and now they would cancel. I could have taken that bottom equation times 1/2. So it turns out there's a bunch of different ways that you can do this, and that's exactly what it's asking down here. Show that the revised system is the solution of the original system, meaning after you multiplied and you got the thing, you got the answers, can you plug them back into the original and it still works? How many of us are checking our answers right now? Ruh-roh. Ruh-roh. We just said, what, 3, 1/2, 1/2, 1/2, 5, -4, 1/2, 3. What was it, 1 and -2? -2 and +2. There we go. Are you checking? 5 times a thing, -5 times a thing, -2 times a thing is 6. 3 times a thing plus 6 times a thing is 6. If you say that that's the answer, it better be the answer for both of them. -2, 2, -2, 2. 10 minus 4. -6 plus 12. Make sure that they work. It's got to work for both of them. Okay. And you saw the progression here, right? First, I was able to eliminate. I didn't have to multiply at all. Then I had to multiply one of my equations. Well, sometimes you got to multiply two of the equations. Unless you're willing to go to fractions. But we all know how much you love fractions. So, uh-oh. What's our uh-oh?
X goes to 1.
3, 6, 3, 4, 6, -4, -1. Yeah? What's wrong with that?
I don't like it.
Yeah, sometimes you end up with gross answers. In this case, I got 3x plus 2y is 1. 4x plus 3y is -2. I think it's fine. We'll see here. Oh, Frank, you stupid son. All right. So thus far, I've been able to take one of them times a thing, and we're good. Can you take 3 times an integer and get 4? Can I take 2 times an integer and get 3? 4 times an integer and get 3. 3 times an integer and get 2. None of those work. So sometimes you're going to have to double dose. I'm going to have to multiply both of them by different numbers to make something eliminate. So you just pick. Do you want to get rid of x's or get rid of y's? Okay. I heard a y's. Who was a y's? Was it you? No. Okay. It doesn't matter because what's the smallest number that 3 and 4 go into? 12. What's the smallest number that 2 and 3 go into? So your choice. Do you want to make the x's 12 and negative 12 or make the y's 6 and negative 6? When in doubt, use smaller numbers. So if I take this times 3, distribute, I'm going to call that 9x, 6y, 3. What would I have to multiply the bottom by to make things cancel out? Okay. If I take this times 2, I get 8x plus 6y is negative 4. If I add them right now, will things cancel out? Now I can subtract though, right? But the negative is the bane of the math student. If I say subtract all these terms, how many of us are going to forget to subtract a negative 4 really means add a 4? Oops. So what I always recommend for kids, just make them opposite signs so you can add. What if I take it times a negative 2? Now it's negative 8x minus 6y is 4. I missed the negative when I looked at yours.
So I must be completely wrong.
You missed a negative somewhere when we wrote it. If I multiply by negative, now my y's just poof out. I get 1x and 7. So I had to double multiply. I had to double distribute to make this work. But now that I have x, go back and find out y. Doesn't matter which equation you use. I'll use the top one because it's got smaller numbers. 3 times a thing plus 2y is 1. Just my personal preference. Plug in a 7. Get 21 plus 2y is 1. Subtract 21. Divide. Double multiplication. Y'all, this was one way to do it. This was only one way to do it. There we go. What if instead I decided I wanted to get rid of x's? Take this times 4, this times negative 3. 12x, 8y, 4. Negative 12x minus 9y is 6. I get 10y negative divide. We still got y as negative 10, getting rid of x's first. So it doesn't matter. You use the path of least resistance for you. Which is the easiest for you? Which one makes the most sense for you? You could have that kid, you all know that kid, that comes along and says, I'm going to take this times a negative 3/4. 3x, 2y1 times a negative 3/4 is now a negative 3. Times a negative 3/4 is now a negative 9/4 y. Times a negative 3/4 is now a positive 3/2. It's still going to cancel. I'm going to get a negative 1/4 y. I'm going to get 2 1/2 5/2. And when I multiply both sides by negative 4, sure enough, negative 10 again. So it really does not matter what you multiply by and which you eliminate first. As long as something's gone and you followed math law, you're right. You got just enough time for you to try one of them. There you go. Notice they used 4 and 3, 3 and 2 again. So they're being nice, keeping it familiar. It's your choice.
Just reduce the same nourishment as well.
You can do that. Well, you can mostly do that. Watch your signs. Because noticed in our example problem, they were all positive, but this time one of them's negative. That's going to change things just a little bit. Minus 17 times 2 is negative 38. Negative 68. Negative 4, negative 4. 2, negative 1, negative 4, negative 1. Are they both positive?
I'm curious. I don't think so. I mean, go look at mine.
No, x is negative 4. Ah!
Wait, X is.
That changes your y.
You want to look at that?
Okay, by 2, by 3, gotcha. 2, 2, yes. 3, 3, 3, yes. If you owe me $38 and I'm dumb enough to let you borrow 30 more,
Wait, what?
you do not owe me $8 now.
So it's negative 38 plus 30?
No, negative 38 minus 30 is additional negatives.
Negative 1x equals negative 38 minus 30. Negative 60, is that
Yes. There you go.
I'm having troubles with the signs. Did I?
You're
Did I
correct.
add it
Keep going.
correctly?
Divide. It works. Out of curiosity, since you're all at least halfway through the problem, did you get rid of x's or get rid of y's? Okay.
Are you sure x is the negative?
Uh-huh. I would also get rid of y's first. You can get rid of either. But for those who did y's, why? Smaller numbers. That's good enough justification. For me, I see that one is already positive and one is already negative. That means I don't have to multiply by a negative. If I don't have to multiply by a negative, that's one less thing for me to screw up. I'm going to take the top times 2 and the bottom times 3. Getting 8x, 6y, negative 38. Getting 9x, negative 6y, negative 30. When I add those together, y's yeet out, 17x is now a negative 68. And when I divide, x is negative 4. Good?
One minus,
Yes, that's good.
8 minus 9 is negative 1. Correct. I don't understand.
If this is already positive 6, negative 6, I don't want to subtract them. 6 minus 6
Oh. Okay.
is 0, cancels
1
out.
minus 7, then I got a negative 68, and then a negative 68 divided by a negative 1 is 68. So my x ended up being 68.
Okay, so you're adding some of them and subtracting others. That's where we're going sideways on it. Okay, just give me a minute and I'll come over. You're like, you literally took a right one block too soon. You're okay. Once you got x, plug it back in. Okay, 3 of those minus 2 of those. Get negative 12 minus 2y, negative 10. Add 12 over. Divide. Negative 4, negative 1. Get your practice in because Friday is going to be more practice with this and then words. Ew, words.